We're going to talk about GME very, very soon, but now we move to our next epoch, which was the LSI era of 68 to 75, and you would say that that was started on July 18, 1968, when Intel was founded as a pure semiconductor memory company. However, historian David Laws says that prior to the founding of Intel in July of 68, there are quite a few other semiconductor companies making memories. Fairchild GME, which is somewhat questionable, and maybe Bernie will comment on that, IBM, Signetic, Sylvania TI, Transitron, and others. We're shipping bipolar and MOS semiconductor memories, including shift registers, ROMs, and RAMs in volume. So at that particular time, let's say around 68, who were the viable companies, and what's the story behind the GME, which is somewhat of a recluse in Silicon Valley? Well, so Dave, and then Bernie address this one.
Well, as I said earlier, GME was founded by 4 guys out of Fairchild. I think it was 64, either 63 or 64, on to commercialize this brand new MOS process, unfortunately, as Ted pointed out, long before it was mature and reliable. They took on a huge contract from Victor Calculator to build a set of 22 100 gate, that was LSI MOS chips, and I think 4 100-bit MOS shift registers to build this calculator. And Phil Ferguson, who was president of the company for a long time, told me many stories of taking one calculator back east to show to Victor, and they never got one to survive the flight to even demonstrate it there because of all the problems they had. The company was eventually bought by Philco Ford. Philco essentially closed it down and moved the stuff back to Bluebell, but they were probably making the first commercial MOS memories if you consider a shift register memory. But really the biggest builder of memory, semiconductor memory, was IBM. They had built a 16-bit chip, they'd built a 64-bit chip.
That was for internal use, primarily.
This is entirely for internal use. And they built a 128-bit memory that was the first
AT&T Micro?
memory. AT&T Micro was not a big factor in memory for a long time in those days. But there were lots of people building 16 and 64-bit RAMs and shipped them in pretty high volume for scratchpad memories. And in fact, Intel's first product was the Schottky version of that popular 64-bit RAM.
For those who don't know, scratchpad memory was like a high-speed register file for a CPU. It wasn't used for instruction memory or data memory. Bernie, you want to comment on the semiconductor companies here?
Well, I was going to comment a little on GME.
Okay, please.
GME had no sales department. Colonel Lowell used to just go around giving speeches, and he said he didn't need salesmen. The word would pass, and they would buy from him just based on the fact that he was in charge of it. They had no sales.
He was such a well-known person that the company...
No, he thought he was. He was a colonel for the Marine Corps.
His reputation?
And his reputation, and their products weren't working, and Noyce was still at Fairchild, and he would just heard from someone that he gave a speech. They're building their 3rd plant to take care of all their demand. And he wanted to know why no one knows who they're selling to. Well, they weren't selling to anybody, but they kept promoting they were selling. So after a year, the colonel was removed from the office, and Phil Ferguson assumed the position of CEO until they were sold.
Ted, I hear that companies like AMS, AMI, MMI, and others were making semiconductor memories just prior to the formation of Intel. What was your thought process of that? And I know we've heard this before, but you might say, aren't you a little bit skeptical about Intel, seeing you thought there might have been too many semiconductor companies already before Intel?
Well, there were several things about Intel. One, the reputation that Noyce and Moore had. In other words, if anybody was going to succeed, you'd figure those 2 guys would do it. But as far as some of the other companies, they were just getting started about the same time as Intel, so there wasn't much word out there yet about them.
AMS a little bit ahead of Intel?
I think about the same time. And then there was a company back east called Kogar. And Kogar came out of IBM, and in some sense, I think IBM spoiled some of the people that worked there. They were used to a very unusual, how would I say, profit structure or marketing structure. IBM seemed like they could sell a computer of a given, you might say, quality and standard at about 4 times the price that anybody else could. So the other thing was, I had heard about the problems at GME, and they explained to me that one of the main problems was contamination of the gate oxide in MOS. And that was supposedly the presence of sodium ions, which would move under bias conditions and change the threshold so that the part eventually no longer would work at the stated operating conditions. And they assured me that the new process that they were working on, the silicon gate process, would prevent contamination of the gate oxide. The other thing that limited the ability to make primarily bipolar memories was, in fact, it was mentioned here earlier, to make a bipolar transistor run fast, they used a technique called gold doping, which basically killed minority carrier lifetime and reduced the gain a bit, but it tended to make the transistor not show a certain funny characteristic when it went into saturation. In other words, you turn the transistor on, and then it would take almost forever, it seemed like, to turn the thing off. It would just sit there conducting until you managed to pull a lot of charge out of the base. So a new process they were working on using Schottky diodes. And the Schottky diode was basically an aluminum to N-type silicon contact, and it acted as a diode but with about half the forward voltage drop of a normal silicon junction diode. And they put this around the collector base diode, and it would prevent the transistor itself from going into normal saturation. And the Schottky diode had little or no storage characteristic. So it made a much faster transistor, but it also eliminated the gold doping step, and the gold doping step was seen as a major yield killer.
When I came here in 1970, everyone thought the next generation memories would be based on Schottky bipolar memory cells, and yet that didn't happen.
Well, there were quite a few. I mean, the 3101, Intel's 64-bit bipolar memory was done with Schottky.
Faster than MOS memories.
Oh yeah, they were considerably faster until we got into the later generation N-channel processes, and then we started seeing, I think some of the early 1K static MOS RAMs, they'd come out with a spec of something like 60 nanoseconds, but under normal conditions at room temperature, they would actually have about 20 nanoseconds access. They're just very conservatively spec'd.
That's the access time.
Access time.
Actually retrieve the contents of the cell.